Good morning, everyone. Today we are going to discuss about one of the lab experiments of computer networks, which is implementation of the data link layer framing methods like character stuffing and also bit stuffing. Before going to character stuffing and bit stuffing, we need to know about the framing in data link layer. Framing is nothing but it is one of the responsibilities of data link layer, which is the division of stream of bits from network layer into manageable units. So these units are called as frames. Okay, see, before going to do this one, see here, these are the layers we have. So first of all, we have the physical layer, data link layer, and here network layer. So from network layer, suppose the data is coming to the data link layer, from the network layer to data link layer, and data link layer to physical layer, it is moving at the sender side. Okay, at the receiver side, actually the same data which is coming from the physical layer. Okay, so this physical layer to the data link layer is moving upward direction, and also to the network layer. So here the main responsibility of data link layer is at the sender side, it is taking the information from the network layer and it is adding the delimiters, means a flag, header, and also trailer, and also one of the flag which can be added in the data link layer, and it can be sending to the physical layer. At the receiver side also, it is taking the data in the form of zeros and ones in the physical layer, then it is coming, it is sending the information to the data link layer as well as to the network layer. So the responsibility of data link layer is nothing but framing. So this is the main information about this framing. Okay, let's coming to the topic. See, what is the main purpose of stuffing is nothing but we can add some bits in the bit format, I mean bit stuffing. And suppose if you are doing character stuffing, we can add some characters in the bit data frames. See here, in the data link layer, the stream of bits from the physical layer is divided into data frames. So we know this one because data link layer is responsible to convert the data into the frames. Okay, and the data frames can be fixed length or variable length. If it is fixed length, there is no problem, which we can send directly to the physical layer. But here in variable length framing, the size of each frame to be transmitted may be in different way. So a pattern of bits is used as a delimiter and to mark the end of one frame and the beginning of the next frame. And here, if the pattern occurs in the message, suppose the data, whenever the pattern is occurs in the message, that means we have the payload as well as, see, the payload is coming, which is coming from the network layer. And here we can add one header, trailer, and also some flags. Okay, see here in the flag, suppose the flag bits are same as in the payload, then it will be a problem. So how we have to solve this problem using this using this bit stuffing and byte stuffing? Let's see. Next, here we have two common approaches which we can solve the problem. Like as we know about the flag information and also the header trailer, and the next ending flag will be there for each and every frame. But if the frame in that frame, if any flag is existed in the payload field, then it will be a problem. So how this problem can be solved? By using byte stuffing and also bit stuffing. So byte stuffing, which is a byte is stuffed in the message to differentiate from the delimiter. See, this is the delimiter, which we can call it as a flag. So this can be differentiated from the delimiter, and this is also called the character oriented framing. We can stuff one more delimiter in the payload field. And here, when coming to the bit stuffing, a pattern of bits of arbitrary length is stuffed in the message to differentiate from the delimiter. So this is also the same thing, but here bitwise we are doing, but here we are doing in the form of bytes. Okay, that means character, and here we can make it in the form of bit oriented framing. Okay. Next, coming to bit-oriented protocol. See here, bit stuffing. This is also called as bit-oriented protocol, is also called as bit stuffing. So bit stuffing is the mechanism of inserting one or more non-information bits. So which is non-information bits. So that means which is not affected to the payload field. So which is we are inserting non-information bits into the message to be transmitted to break up the message sequence for synchronization purpose. See here, this is the payload field which is coming from the network layer. Okay, which is coming from the network layer. This is the payload field. So in this payload field, suppose if any flag is existed, like here, see in this flag we have 8 bits. We have 8 bits. See here, 1, 2, 3, 4, 5, 6, 7, 8. The first and last are zeros, and remaining are all ones. Suppose if any ones, the same 1, 2, 3, 4, 5, 6. 6 ones are existed in the payload field, that will be treated as a flag. Because of framing is like that. Framing is starting from the flag and ending is also with the flag. Okay, so at this situation, how we can solve this one? That is by inserting one more delimiter. See here, this is in this example, in this bit stuffing mechanism, we have the data like this. So in the flag field, we have the first and last characters are zeros and remaining are all ones. That means 1 0, then 6 ones, and after that 0. So consecutive 6 ones are there in the flag. If suppose consecutive 6 ones are existed in this payload field also, then it will be treating as a flag. That means it is ending with the frame. So it can treat it as a ending of the frame. So that situation we have to avoid by using this bit stuffing. How we can using this one? That means here, if any consecutive 5 ones are existed, then we can stuff with 1 0. So it is not to be treated as a flag, because flag can be consisted of consecutive 6 ones. Okay, so but here we can have one more 0 after consecutive 5 ones. So this is called as bit stuffing. Okay, and at the receiver side, this is the receiver side of data link layer. So at the receiver side, when you send the information, bit stuffed information to the receiver side, then here the receiver can understood that if any consecutive ones and followed by 0 is there, then that can be unstuffed. That means they can taken out from the data. So after taken out from the data of these things, these two zeros, then it will be called as the payload field of that particular data. Okay, so this data can be transmitted to the network layer at the receiver end. Okay. Next. So this is the example of bit stuffing. See here, in this bit sequence, this is the example. See here, we have 1, 2, 3, 4, 5 consecutive ones, and 1 0 is there. And here also we have 6 ones and 0, and here also 7 ones and 0. So this is without bit stuffing. That means this is directly coming from the network layer. But here we are going to insert one more bit field, that is 5. If any 5 consecutive ones are existed in the bit sequence, then we can add one more 0. See here, 5 consecutive ones, then we can add 1 0, and here also 5 consecutive, after 5 consecutive ones, then we can add one more 0, and here also one more 0. So this is after stuffing. This bit sequence is after stuffing. So at the time of at the end of receiver side, they can easily understood that if any 5 consecutive ones are there, they can remove the 0, then remaining data can be treated as payload field. Okay, next, this is the algorithm for bit stuffing. See, first of all, in this algorithm, we can start, and here the initialize the array for transmitted stream. So we need the data that is in the form of input. So this is the input, that is nothing but payload field, which is coming from the network layer. So that is that data is treated as an input, and which indicates the beginning of the frame. Okay, but here this is 1 2 3 4 5 6 0 and 0. Sorry, here this can be treated as the flag one. Okay, so this can be treated as a flag one, and one more input value is payload field, which is coming from the network layer. So get the bit stream to be transmitted into the array, and check the 5 consecutive ones, and if they occur, stuff a bit 0, and display the data transmitted as it appears on the data line after appending 0 triple one triple one 0 at the end. So this is adding flags. This is the adding flags before the payload field and after the payload field. For destuffing, at the time of destuffing, so where we can do this destuffing, this is at the receiver side. So the it can copy, so we can copy the transmitted data to another array after detecting the stuffed bits. Suppose if you find any consecutive 5 ones, after that 0 is there, then immediately we can take a out from the data. So then receivers can display that receiver bit stream, and then it can be stopped. So this is the algorithm for bit stuffing. Okay, next. So coming to the character oriented framing. So this is character stuffing, and also we can call it as byte stuffing. So it is a special byte called the escape character is stuffed before every byte in the message with the same pattern as the flag byte. If the escape sequence is found in the message byte, then another escape byte is stuffed before it. Okay, see, actually, see, escape character is stuffed before every byte in the message. So each and every frame we have to, every byte in the message we can stuff with the escape character. So here in the same pattern, the flag byte is also. If the escape sequence is found in the message, see in this is the payload field. Okay, that is coming from the network layer. So this is the payload field. So in this payload field, if any flag is occurred, the same flag is existed in the payload field, then what we have to do? We have to insert one more escape. We have to insert one more escape. So that is if any flag byte is occurred in the payload field, we just adding one more escape. So this is nothing but character stuffing. So before the flag, if any flag is existed here, for example, suppose flag is existed here, then we should insert one escape character before the flag. So this is the way we can do the character stuffing. Next. So this is the byte stuffing mechanism. See here in the data field. So this is network layer data, which is considered as a payload field in data link layer. So it is having one flag and also one escape. Okay, one flag and one escape. See here, this is starting from here to here. This is the payload field. This is the payload field coming from the data link layer. But flag is there. This is considered for the starting of the data. Okay, this is starting of the frame. So the same flag is existed in this payload field. So what we have to do, and suppose if it is existed in the payload field, then we just insert the escape character before the flag. And here, suppose we are going to insert escape. Suppose the same escape is existed in the same payload field, then what we have to do, the same escape, if you can insert one more time in the payload field, then it is understood that the receiver can remove or taken out from the data. I mean, from the payload field. Okay. So two escapes are there, then we can easily remove or we can easily taken out from the data at the receiver end. See here, in this is the receiver side, and here it is sender side, and but here it is receiver side. At the receiver side, if any escapes are there, then we can remove or we can taken out from the payload field. See here, one escape, and here two escapes are there. So Emma, from these two, we can taken out only one. Okay, we can taken out only one. So that means we can taken out this escape and also this escape. So immediately we'll get the same field, which we can consider for the uh, payload field. So that can be considered as the network layer data. See here, the same thing we can transmit it to the network layer. Okay. Next. See here, the main serious problem occurs when binary data itself will contain flag bytes bit pattern. This situation will usually interfere with the framing. So the main solution is character or byte stuffing. So where sender's data link layer insert a special escape character just before each accidental flag byte in the data. Suppose if the same flag is existed in the payload field, then immediately we can insert the escape field. Suppose the escape is also existed in the payload field, then we can add one more escape in the payload field. Okay. At the receiver end, data link layer removes the escape byte, before the data are going to the network layer. Okay. So this problem we can solve by using character stuffing. That is flag bytes occurred in the character, in the payload field. That is one serious problem. Uh, and also in the bit stuffing also we have the same problem, but in the form of bits. But here in the form of bytes, means characters. See here, this is one of the example of byte stuffing. Here flag, header, payload field, trailer, and also flag. This is the framing. This is the frame. One frame specification for the frame, and here this is the original characters for the frame. These are the original characters. See, these are the original characters. See, when considering first one, see here A flag B. Suppose the payload data, only the payload data. So we have to consider only the payload data for the original characters. Suppose the payload data is A flag B. Flag is already existed in here. See, this is the start. It can considered as a starting delimiter of each frame, but it is accidentally happened in the payload field. So what we have to do, at the stuffing, at the character stuffing before the flag field, we can insert one escape. Okay, we can insert one escape. Suppose in the second situation, we have escape is existed because we are inserting the delimiter before the flag, that is escape. But the same is existed in the payload field. Then at this situation also we can add one more extra escape data. Okay. And here in the third situation, both is happening, escape and also flag. What we need to do, before escape we have to insert one escape, and before flag also we can insert one more escape. So that is stuffing. So before that we are going to stuff one escape character. And here also see two escapes are there. Original data in this fourth situation, the original data consists A escape B. So I think you understood this one. That is inserting two more escapes before the escape characters. So these are stuffed one. These are all stuffed ones. Okay. So this is the example of byte stuffing. Okay. This is one more example. I think it is also completed. So flag and escape, before flag one escape we can insert, and here also before escape we can insert one more escape character. So at the receiver side we can remove or taken out these two escapes from the payload field. Then this is one of the example. See here in this example, enter the message to be sent. So suppose if you do any program, in that program, the payload field is like this: DDE, DFF, DE. So if it is the payload field, actually E is the escape character, F is the flag character. Suppose flag is represented by F, and escape is represented by E, for example. Okay. For example, escape is represented by E and flag is represented by F. Okay. So at this situation, what we have to do? See here, we have one escape, two flags and one escape. Okay. So in this data, we have two flags and also two escapes are there. So but each and every frame, see this is the frame. Okay, this is the frame. So in this frame, what data is there? D, D, E, D, F, F, D, E. Okay, so this is the payload data. Okay, this is the payload data. So before the frame, before the payload and after the payload, we have to insert the flag. We have to insert the flag. So what is the flag? F. And here also one more flag, that is F. See, these two flags are represented by the frame. Okay, starting of the frame and ending of the frame. These two are representing like this. In this example, F I am taking for the starting delimiter, and this is the ending delimiter. Okay, this is starting index, I mean starting text, and this is the ending text. So this is the data we need. Okay, see, E is escape character, which as I said here, escape is considered as E value. So before E, one E, so D, D, E we have to insert. E we have to insert one more time, and here D normally we can write here, and F is nothing but flag. So before flag, what we need to do? Escape we have to insert F, and then here also flag is there. So before this flag also we have to insert one more escape character, that is E and F. See here D is there, D we can immediately insert, and E is there. E is nothing but escape character. So one escape character is existed, then we need to insert one more escape character before the data. See, so here one stuff, and this is stuff character, and this is also one stuff, and here also one stuff. Okay, so these two are same. Okay, starting delimiter is f and ending delimiter is also f. Okay, so we are going to insert extra escape character before the escape character as well as before the flag character. Okay, understood? Like this way we can add. So this is nothing but after stuffing the data is like this. Okay, so this is the data. Okay, so this is at the sender side. At the receiver side, this data is transmitting to the receiver. So what receiver can do? The receiver can immediately taken out the first and last flags. Immediately they can taken out. And if any consecutive is are there. See, D is there and two E's are there. E means nothing but escape. So two escape characters are there. One they can remove. That means before one. Before the, one, the first escape character can be removed and only one can be inserted in this data. And then D, and here one escape character is there, then F is there. So it is understood that flag is existed, but it can be removed and F can be stored. Okay, then here escape character, then flag field. So immediately this can be removed and F can be stored in the data. Then D directly it will come, and two E's are there. So that means what? The first one E can be taken out and last E is going to place in the data field. That means payload field. So this is the receiver end. This is the receiver end. Okay. And coming to algorithm. So this is the character stuffing algorithm at the sender side. First, start and then append starting delimiter at the beginning of the string and check the data if character is present. Okay, which character? The starting DLE. DLE is the flag one, and that is if character DLE is present in the string, then we can add one more DLE. Okay, see, for example, doodle. Doodle is the data, but DLE is what? Here the flag. DLE is the flag. Okay, so one DLE is existed here. This is the DLE existed. So what we have to do? We need to insert one more DLE. One more DLE at the sender side. Okay, and after finishing of this character stuffing, then we need to insert one more flag, that is at the ending text. At the ending text we have to insert DLE, one more DLE at the ending text. Okay, and display the string. So this is the string. Before this, before that, before the doodle, DOO DLE, and one more DLE is going to insert, and this is the payload field, and starting delimiter is DLE STX, and here DLE ETX. ETX is the ending text. So in this example, I'm taking the flag is DLE. Flag will be DLE. Okay, this is the starting, and this is the ending. Okay, so DLE is the flag one, and here also DLE is the flag. This is the starting of the frame, and this is the ending of the frame. Okay, so here one more DLE is inserted. So the same thing can be, see here, this is at the receiver side. This is at the receiver side. So what we have to do here, we have to ignore the starting delimiter, I mean that is DLE STX. So this we have to neglect, that means ignore. And DLE is present in the text. So if it is existed any DLE one time, so that is also we have to ignore. That means we have to neglect this one. And then copy the same to the output. So that means if you neglect this one, then what is the value? DOO DLE. So this is the value. And then we have to neglect the ending text, ending delimiter. Okay, so this, and here stuffed one, and this is the ending delimiter. So if you taken out this one, then we'll have the correct information that we have to send to the network layer. Okay, so this is the algorithm for character destuffing. Okay, I hope you understood what is bit stuffing and what is character stuffing. Okay, thank you for watching.